So how can we integrate y equals to e to the power of minus x squared, which is the bell curve? And I told you before the integration of this part, right? Okay, should be square root of pi. Okay, why? Okay, can we just get an analytical solution so that whenever we designate a certain interval, we could get the area of this bell curve nicely and easily? And there is no analytical solution doing it, unfortunately. So this is why when it comes to normal distribution and then the probability mass, we refer to the normal distribution table instead of trying to get the functional value out of it each time. Okay, and to get to this part, mathematicians came up with this trick called Gauss integral. Okay, how does that work? Okay, here they did it this way. Okay, let's call this guy as A because it's area, black, pink in an area. Okay, black, pink in your area, and there, what do? Well, a squared, and we are going to take the square root of the result later on. Okay, what happens over here? Okay, so it's going to be very interesting. So watch this guy. So this one is minus infinity to plus infinity e to the power of minus x squared dx, and the same thing, and e to the power of minus x squared dx, the same thing. Okay, it's just a multiplication. Now we realize, okay, in the second integration, we realize that the x are just, is just a dummy variable for integration. So we can switch this x into any other letters like y. So why don't we just switch it to e to the power of minus y squared, okay, and to the infinity. Dummy variable just changed, okay? And then the first term, okay, the integration stays the same, okay? Then we know that integration, this is nothing but double integral and e to the power of x squared and e to the power of minus y squared dx dy. And we know that this guy should be nothing but e to the power of minus x squared plus y squared parentheses x dy. I'm omitting infinity over there. Okay, now what? This one, well, looks awfully like the equation of a circle. Okay, equation of a circle using Pythagorean theorem and kind of things. You see, well, if we think about x and y coordinate, okay, and 0 and x and y over here, okay, this is x and y, and then this one, okay, x squared plus y squared being equal to r squared. We can think about this radius, okay, kind of things, and then a theta angle that represents this, okay? So there are two different ways of representing the position of any dot, okay, any dot. Where are you? Where are you? We can think about, Cartesian coordinate system x and y, okay? To x direction, how many steps, and y direction, how many different steps you take, okay? Angle, okay, like a taxi metric, like x and y. That's one coordinate system. The other coordinate system is polar coordinate, where it's more like a radar. Here is your headquarter or your radar center, and then your radar is boom, going down or all around, and then your enemy plane over there is identified. Where is that guy? Well, the way you talk about it is how far away from your headquarter, and then what's the angle, okay? Which direction do we have to shoot that guy? That's the idea over here. So if we switch it to a different color like this, we can think about like the circle. Okay. So in that respect, well, we can represent our theta, okay, as a coordinate, the polar coordinate system. From here, the Cartesian coordinate system, we want to switch into polar coordinate system and see how this integral changes from the infinities to different things, okay? How can you switch, okay, our coordinate system? And if we switch the coordinate system, what should happen to this dx and dy? Because this dx and dy is about the how do you say infinitesimal area dx and dy. This is dx and dy, the square kind of the rectangle that we are integrating, okay, across a third dimension, 3D subjects. We are integrating with respect to this dx dy rectangle, right? This rectangle unit has to be changed as we switch the coordinate into dr and d theta system. So dr d theta system, we switch it. Then we have to multiply r over here, okay? Why r? Okay, why r? Here's my way of explaining it. Two different ways. One is like this guy, okay? This system, right? Polar coordinate system, if we try to switch, right? Here is my, yes, green line, okay. The way I do it will be like this. In the polar coordinate system, there you will have to change the angle slightly, change the angle slightly, and then the length has to, what is that, the radius has to also increase slightly, okay, okay. The same area, approximately this orange area with the rectangle representation. In a polar coordinate system, you can approximate it with this kind of I don't know how to say it in this, not a rectangle, but this part of this radius, right? Like this, okay? How can we represent it? Well, the thing is, here you see the increment is dr, and then the angle over here, okay, the slight change of angle, we call it d theta, okay, d theta. And then the thing is, the area over here will be equivalent to dr times something over here, okay. This length is nothing but r, r times d theta, okay. This one should be r times d theta, because if you look at any circle, okay, any circle, here is any angle phi, and then here is r, okay, then this length will be r phi, okay, that's this guy. So give me the angle and the radius, this guy will be determined as r phi. The same idea holds true over here. So what used to be represented with the square, the rectangle dx dy, now it should be represented as r times dr d theta, okay, r times dr d theta. So because of the radius system, okay, and then how should this guy change is the next question. How should that be changed? There, if you think about any point in x and y coordinate, okay, this guy, okay, here's the hypotenuse. What is it? The x is over here and y is over there, and this guy will be x and y. At the same time, this is right angle, right? Perpendicular. And then this guy, x will be r cosine theta, and y will be r sine theta. Okay? The same thing. Same thing. Okay? So much so that x squared plus y squared will be equal to r squared. You see cosine squared and sine squared should be equal to 1. So that's why this relation should hold true. Okay? And there, um, this integration, okay, this integration is a integration of 3D object, a bell-shaped 3D object, okay, across the 2D dimension, right? Flat XY plane, okay? But if we interpret this as a 3D integration across r theta plane, then how does that change, right? X squared plus y squared should change into what? R squared. So the integration will change into this nice form. Okay, nice form. Let me change it into purple. And then, yes, this, okay, minus infinity to plus infinity, e to the power of x squared plus y squared dx dy should be changed into e to the power of r squared minus r squared because of this relation. And then dx dy should be changed into r dr d theta. And then the theta should be changing from 0 to 2 pi. Okay, because it's the angle world, right? All you have to do is just to take one round. Okay, 0 to 2 pi. And then r, that has to be from 0, from the origin to the infinity, like this. Make sense? Right. Then what do? Well, you realize there is no theta involved over here. So the theta, okay, just take this 2 pi d theta outside, and then 0 to infinity, e to the power of minus r squared, r dr separately. And now you realize that the first integration is nothing but 2 pi. Okay, this guy. The second integration, what can you do about it? 0 to infinity, e to the power of r squared, r dr. Then, here we do one more trick. Let's call this r squared as just alpha. R squared, I'm going to call it alpha. Okay? Now, if we take the derivative of both sides, it's going to be 2r dr being equal to d alpha. Okay? Well, wait a minute. How did you do that? Because I assumed take the derivative of dr. Right. Okay. From d to the d alpha. Both sides. If we take the derivative of the left-hand side, it's going to be 2r being equal to d alpha dr. I just took this guy to the other side of the equation, and that's how things work nicely like this. Okay? So bring this guy, which means r dr should be equal to 1/2 d alpha. Okay? So I'm going to bring this guy into here, r dr. Okay? And now that's 2 pi times 0 to infinity, and then e to the power of minus alpha, and then this guy, 1/2 d alpha. Okay? And then 2 cancels each other out, and then we are left with pi, and then 0 to infinity, e to the power of minus alpha d alpha. By the way, we learned that this guy should be equal to none other than 1. So that's why it has to be equal to pi a squared. That means a has to be square root of pi. Minus pi, well, you know this is area, so you cannot take negative value. So that's why this holds true. Okay? So the bell curve area, okay, we know how to solve it using Gauss integral. Gauss integral. Okay, so thanks for watching.